Okay, on the back of the notes, we're starting with a definition. We need to define the complement of a set. So the complement of a set is just all outcomes not appearing within the set. And to give you an example of that, if we're talking about numbers and your set is even numbers, the complement of those is odd numbers. Right? If we're talking about the percent chance of rain tomorrow, if the percent chance of rain is 70% and your set is odds that it will rain, then the complement of that is going to be the 30% chance that it does not rain, right? So it's just the opposite kind of. So it's within your parameters that you've set. It's all the outcomes that do not appear within the set. So, for example, in a deck of 52 cards, it's just your standard deck of cards. If you don't know what cards are, this is a description of what cards look like. You got 4 suits: hearts, diamonds, clubs, and spades, and they're labeled numbers 2 through ace. So set A is defined as all hearts, and B is its complement. It's asking to determine the probability of A and the probability of its complement, which is B. So all hearts. Well, we know that there are 4 suits, so there are going to be 13 cards that are hearts out of the 52 in the deck, which ends up being 1/4. All right, so that's the probability of A. And I'll just write that off to the side here. If B is its complement, then it's all the others, right? So it's going to be 52 minus 13, essentially. So probability of B is going to be 39 out of 52, which reduces to 3/4. And what you're noticing here is that the complement is the missing amount from the set that was given. It's saying, what is the probability of A plus the probability of B? Well, 1/4 plus 3/4 is 4/4, which is 1. Do you think this will be true of any set? It will be true of any set, because if the complement is all of the values that are not within the set, and the whole set has to, or the whole scenario has to add up to 1, then your set plus its complement will be all of the values possible. And the definition I've given here is basically just saying that the probability of the complement of some set of A is equal to 1 minus the probability of A, and that's your complement. In this case, it ended up being B. All right, so practice. If the probability of being given an ice cream cone with dirt on it is 1/3, what is the probability of receiving a cone without dirt? Well, that's going to be the probability of the complement. So it's going to be 1 minus the probability of dirt, which is going to be 1 minus 1/3, which is 2/3, or 67%. All right, so that's just a quick, easy application of what we just learned. If the probability of being born with blue eyes is 26%, excuse me, what is the probability of being born with any other eye color? Well, if the probability of being born with blue eyes is 26%, any other eye color is going to be its complement. So you're just going to subtract the probability of being born with blue eyes from 1, and that's 0.26, which will leave us with 0.74, or 74%. Okay, another application of the complement there. And the last thing we're going to do is deal with a 6-sided die. It's being rolled, and then a fair coin is flipped. So this is practice drawing those tree diagrams. So first we're going to draw to represent the situations that could take place after the 6-sided die is rolled. You could have a 1, a 2, a 3, a 4, a 5, or a 6. So that's what all of these branches represent. All right, and then after that, at each one of those, that's when you're going to flip the coin. So from that point, you have a head or a tail. You have heads or tails. Heads or tails for each of these. All right, what's the probability that you do not get a prime number in tails? Let me write in my my possible outcomes real quick. All right. What is the probability that you do not get a prime number and tails? All right. So let's try to find those scenarios. You do not get a prime number and tails. Well, let's look at the situations where you do get a prime number and tails, and then just take the complement of it. Prime number, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 prime number scenarios here, but they don't all have tails. So prime number, tails, prime number, tails, prime number, tails, prime number, tails. So if the probability of getting a prime number and tails is 4 out of our 12 scenarios here, which reduces to 1/3, then the complement of that is going to be 1 minus 1/3 or 2/3. And then the last question is, what is the probability of not getting heads and an odd number? So let's see when it is we do get heads and an odd number. Odd number heads, odd number heads, odd number heads. So there are 3 of those. So 3 of 12, or 1/4. So not getting that is going to be the complement of that. 1 minus 1/4, which is going to be 3/4. All right, so we can use the complement to help us make things a little easier. It's a lot less counting if we can just count up the other scenarios and subtract from 1. All right, so that's it for the notes. Good luck on the homework, and I'll see you guys tomorrow.